Welcome students. Today we will discuss the questions for the JEE Advanced from the chapter Properties of Fluids. Now start. Question is a glass full of water of a height 10 centimeter. Now it is given here the height. It means small h is given. Has a bottom of area 10 centimeter square. It means bottom area. We denote it by capital A with the subscript of 1, which is 10 centimeter square. We need to firstly convert this unit into meter, standard unit. Now here we convert it into 10 raised to minus 4 meter square. We will get 10 raised to minus 3 meter square. Why we do this? Because as you know, 1 meter equals to 100 centimeter and 1 meter square equals to 100. As you know, 1 meter equals to 100 centimeter and 1 meter square equals to 100 to the power 4, which is equal to 10 raised to 4 centimeter square. So 1 centimeter square equals to 10 raised to minus 4 meter square. From that, we write here 10 raised to minus 4. So conversion becomes 10 raised to minus 3 meter square. And area of the bottom comes to be 10 raised to 3 minus 3 meter square. Now the area, this is area from the top. So we denote it by area 2 equals to 30 into 10 raised to power minus 4 meter square. 30 into 10 raised to minus 4, which becomes 3 into 10 raised to minus 3 meter square. This is area from the top. Now also the volume of 1 liter. It means, as you know students, volume is given. Volume is given which is equals to 1 liter. 1 liter means minus 3 meter cube. This is also the conversion which is important. Now, question is find the force exerted by the water on the bottom. Now, student, starting from question, no, this is the glass of water. Now, and this is full of water. Now, this is the top area which is given by A2 equals to 3 into 10 raised to power minus 3 meter square, and bottom area is given, we denote it by A1, which is we calculate 10 raised to power minus 3 meter square. And here the height, which is also given 10 cm, which is mean 0.1 meter. Now we need to find the force exerted by the water on the bottom. We need to find the bottom force. Whole liquid which applies force on the bottom area, we need to find it. Now we denote it by F1. As you know students, force is equal to pressure into area. Now pressure is equals to, as you know, it contains the liquid which is water, and the density of water is given here. And as you know, the pressure formula is rho gh and multiply by area. Rho is the density, g is the acceleration due to gravity, h is the height. As the height is given 0.1, density of the water, because the liquid is a water, 10 raised to power 3 multiply by acceleration due to gravity, as you know, 10. Height which is given 0.1, and the area comes to be the bottom area, which is 10 raised to power minus 3. But there is also a top force which is called atmospheric pressure, P naught, also acting on the top. So here we also included plus P naught, and P naught means atmospheric pressure. So the value of P naught comes to be 1.01 into 10 raised to power 5. Now student, calculate. This becomes 10 raised to power 3 multiply by, this will cancel, minus 3 plus 1.01 into 10 raised to power minus 5. Also area is 10 raised to power minus 3. Rho gh, this area will also multiply here. This become 1 plus 1.01 into 10 raised to power 2, and the answer comes to be 102 Newton. And this is the force which is F1, which will acting on the bottom surface of this glass, and this is the answer number 1. So the force which comes to be at the bottom is 102 Newton. Hope you understand the first part. Now come to the second part. Now find the resultant force exerted by the side of the glass on the water. Now we need to find what force will be acting by the glass on the water. Now this is a side force. Now it would denote it by capital F. There is also a force which is acting by the glass on the water. We denote it by F3. And there is also a weight W which is acting downward by the liquid. So firstly we need to calculate the force which is acting on the top. As we know, F2 force, we denote it by, which is comes to be F2 here, which is equals to pressure into area. Now there is no height above the surface, so the pressure only comes to be the standard pressure. So the F2 equals to 1.01 into 10 raised to power 5 into area 2, which is 3 into 10 to the power minus 3. Now come to the calculation. 1.01 into 10 to the power 5 multiplied by 10 to minus 3 into 3. Here 3.03 into 10 raised to power 2, which is equals to 303 Newton. Now here comes the force. F2 equals to 303 Newton. Now this is the force which will acting on this surface by the atmosphere on the surface, top surface. Now, but here we require the resultant force exerted by the side of the glass on the water. From the equilibrium, now from the equilibrium equation, as we know, the force F2 acting in this way, weight will also acting this way, but the side force, which is we need to calculate F, and the bottom force F3 in upward direction. So from equilibrium point condition, F2 plus W equals to F3 plus F, and this is the F we need to calculate. But here we have the F1, we need to calculate W and F3. Now we calculate here W. As you know, weight is equals to specific weight of liquid multiplied by volume, and the specific weight is equals to density into acceleration due to gravity into volume. Now the density of water here will be 10 to power 3 multiplied by 10, and the volume here given 1 liter equals to 10 to minus 3 here minus 3. So we from here we will get 10 to minus 3 cancel, we will get 10 Newton is the weight of the liquid in that glass. Also we will get W and F2, but we do not know F3. Now we need to calculate F3 here. F3 is equal to the minus of F1, because this force which will acting on the bottom has to be resisted by this force, by the glass. So the F3 value comes to be minus of 102 Newton, which is calculated in the first case. So F3, we will get the value F3. Now substitute this value in this equation. From that we will get the value of F. Now as we know, F2 value is 303 and the value of W is 10, equals to the value of F3 is minus 102 plus F. Now F is equals to 303 plus 10 plus 102. The answer comes to be the Newton. F2 is the 303 force which is acting, F2 is the force which is 303 which is acting upward, and W is the weight of the liquid occurring on the bottom side, and 102 is the force which is comes to be the, but this means negative means 102 which we consider is at upward comes to be the negative sign. If we remove that, comes to be the downward. So the value becomes here to be negative. Plus 10 minus 102 into minus 102, which will come to be 1.211 Newton. And this is the force, resultant force exerted by the side of the water, side of the glass by the water, which comes, force comes 211 Newton. Now, comes to the third part. If the glass is covered by the jar and the air inside the jar is completely pumped out, then what will be the answer to the part A and B? Now students, we need to calculate this. Now, if the glass is covered by a jar and the air inside is pumped out, now C part. Whenever there is a type of this question, then we need to put standard atmospheric pressure equals to 0. If standard atmospheric pressure is equals to 0, then value of F1 is equals to only, as we know, studied earlier, that F1 is equals to P naught plus rho GH. But here the value comes to be the 0. So only value rho GH will become. So rho G means density of water multiplied by 10, H is the height, which comes to be 0.1 meter. 4 into 0.1 and comes to be 10 to the power 3 Newton. So for the third part, the first force which will occurring on the bottom surface comes to be 10 to power plus 3. And for the second part, for the B part comes to be, as you know, the answer comes to be for the B part, F2 comes to be 0 Newton, because on the top surface the pressure P naught equals to 0. So F2 becomes 0, because when we multiply, as we know, P into area, and the pressure becomes 0, so 0 multiplied by area becomes 0 Newton. So there is no force on the top surface of the glass, and we will get the two answers.